over cos x is actually tan. And then we can now say at this given point that since tan x equals to 7, and in this particular question we are trying to find the x value or the x coordinate, our x is going to be tan inverse of 7, and this is going to be 1.43 as our final answer. Now, the next part of this question, what we are expected to do is to determine whether the stationary point is a maximum or a minimum. So, in that kind of scenario, you need to Yeah, so if you are given a question like this and you are told that a curve with equation y equals to e to 2x sin x plus 3 cos x has a stationary point in the interval 0, x is greater than or equal to 0 and less than or equal to pi, and we're supposed to find the coordinate of this point correct to 2 decimal places. So these are just 2 questions, and there is another part whereby you are supposed to determine whether the stationary point is maximum or minimum. So to begin this particular question here, we are going to focus ourselves and try to see which is the best technique you can be able to use in order to differentiate this function that we have at this particular point. Now, I will start by writing the equation the way it was given. Yeah, let us try to write the equation the way it was given, and we are saying this equation was given as y equals to e to 2x into there is sin x plus cos x. So you ought to decide the technique you can be able to use. You can be able to differentiate using power rule. At the same time, you can be able to use quotient rule if you have two functions which are divided together. You can also use product rule if two functions are multiplied together. So if you can be able to look at whatever we are given at this particular point, you realize and appreciate that in this function that we have here, you cannot be there's no fraction divided, so we have e to 2x multiplied to sin x plus 3 cos x. Yeah, so this is actually plus 3 cos x, so meaning we are going to employ product rule in order to work out this. Remember, if you're having two functions multiplied, so in order to find dd of x of u v, whereby u is and v are the two functions which are multiplied together, we can be able to say, in order to work out this, it will be u dv dx plus v du dx. So this is telling me that in the process of working out this question, I'm going to differentiate each of the bank equation separately, and then I'm going to multiply to one of the function. So we can decide and say this one here, this that we have here, represent our u, and then we can say the whole of this function is going to represent our v. Now, since I need the v dx and I also need the u dx, I need to go ahead and find the u dx. So the u dx of this particular function is going to be 2e to 2x, because when you differentiate e to 2x, you are going to differentiate the top part, if you're given and then you bring it down and maintain the function of the exponent the way it was. Then we are going also to differentiate the other one that we are having here, which is our v. So dv dx is going to be equal to what? So we are having two functions, sin x and 3 cos x. So meaning if we differentiate the first one, it is going to be cos x, and the other one, if you differentiate cos, you get negative sign. So this is going to be minus 3 sin x. Now, once we have gotten all this, we can now go ahead and try to use product rule, and then we now plug in what we have. So dv, you can say dy dx is going to be equal to u dv dx. Our u is e to 2x, then dv dx is this part that we had gotten here, and this is going to be cos x minus 3 sin x. Then we are going to add, according to the product rule, v. We had said our v is this function, so it's going to be sin x plus 3 cos x, then times du dx, and our du dx is this part, so we are going to say this is going to be times 2 e to 2x. So if I'm having this equation like this, I can see I can be able to say, remember we are talking of a stationary point is in the interval. We are supposed to find the x coordinate of this stationary point. So we can say at the stationary point, there's something we know about it. And what is that? We know that dy dx is equal to 0 at the stationary point. So that means in order to proceed from here, we are going to say now the whole of this part that we have can be equated to 0, and this is going to be, I'll factor out e to x, e to 2x. I'll have cos x minus 3 sin x plus this 2 is going to multiply inside here because I've factored out, and that's going to be 2 sin x plus 6 cos x is equal to 0. So at this given point, if you can open your eyes widely, you can see we have cos x plus cos x, which is going to give us 7 cos x, and this minus 3 sin x plus 2 sin x is going to simplify. So in this part, before we move there, we can see now, since this is equated to 0, it means that either 2x is equal to 0, e to 2x is equal to 0, or, okay, let me just simplify this further. It will be cos x, that is going to be 7 cos x, and 3 sin x, negative 3 sin x plus 2 sin x, that's going to be negative sin x, is equal to 0. And now that will mean that this part equals to 0, or this part is equals to 0. But remember, there's no number you can be able to find exponent to give you 0 under this part. So we can tentatively say there and confidently that for this part, no solution. No solution for this part. So we are going to do away with it. You cannot continue with that. So the only part that will be remaining is this part here that says 7 cos x minus sin x is 0. And that means that this can be, we can take this guy on the other side of the equal sign, and we say that if you take a number over the equal sign, or under the equal sign, or through this space between the equal sign, the sign must change. And this is going to be cos x equals to sin x. Now, in order to proceed, we can now say this is the same as divided by cos x divided by cos x, which will mean that this term and this term will cancel out. We end up remaining with tan x equals to 7. So meaning this guy that we have in here, sin x over cos x, is actually tan x. And then we can now say at this given point that since tan x equals to 7, and in this particular question we are trying to find the x value, or the x coordinate, our x is going to be tan inverse of 7, and this is going to be 1.43. as our final answer. Now, the next part of this question, what we are expected to do is to determine whether the stationary point is a maximum or a minimum. So in that kind of scenario, you need to understand, for you to state whether a function is a stationary point, the stationary point is either maximum or minimum. Now for part B, we can find again, since we have obtained dy dx is equals to, since we have obtained that our dy dx is equals to e to 2x into bracket 7 cos x minus sin x. So that will mean that you need to differentiate this for the second time. So if you differentiate this for the second time, you are going to say that this is going to be d squared y dx squared is going to be equal to, we are going to apply again power rule, rather product rule, in order to differentiate this. So we can decide to keep the first one constant 2x and then differentiate this part. So this is going to be negative 7 sin x minus cos x, and then we can also say now this is going to be plus, we differentiate the exponent keeping the other term constant, so this is going to be 7 into bracket, differentiate this one is going to be 2 exponent x, 2 exponent, so we differentiate the top, we bring it down, it's going to be 2, then exponent 2x into 7 cos x minus sin x. So if you are going to work out this question, you're going to realize that we shall have then d squared. The next thing you're going to do is dx squared. You try to substitute to this function the value x equals to 1.43, so that you can be able to see, are you getting a positive value or are you getting the negative value. So that will mean that if you substitute here, you are going to get that the answer you are going to get is actually a negative, which will be equal to a negative. So meaning that d, meaning that our d, okay, let me just try to find somewhere to write. So once you work out that, you are going to realize that our dy dx squared, d squared y dx squared is less than 0, and when you get that is less than 0, that means that this is a maximum point, going to be a maximum point. So that's basically what you do in a scenario like that. So maybe what I can do, I'll quickly take you through another question that you may um, be given. So a question that uses a different technique, so that we can see also how to perform that kind of question of differentiation. So in this question number 2, we are basically going to use quotient rule, because we are given cos x, we are given cos x, f of x is actually cos x over 1 plus sin x. Show that f is less than 0 for all values in of x in the interval negative a half pi, x is greater than negative a half pi or less than 2 over 3 pi. Okay, now since we are told that a function, our function that we are interested with, f of x is cos x over 1 plus sin x. So this will mean that the rule that we're going to use here, we are going to use quotient rule. We're going to apply quotient rule in this particular question. So how does quotient rule state? Quotient rule states that if if you are finding d of dx of two functions which are divided like that, then it means that you are going to say v du dx minus u dv dx, then divide by the v squared. So under this equation, we can say now let our u be equals to cos x, and our v is going to be 1 plus sin x. So as we did the previous section question, since we are going to use dv dx and we are going to use du dx, we can decide and at this first step to find du dx, and this is going to translate to negative sine x. Also, if you find dv dx, this is going to translate to cos x, because if you differentiate this first term, it will be 0, and differentiating the second term, which is sine, is going to give you a cosine. Then now we can now say our f prime, or the differential function to this, is going to be v. Our v is actually this guy that we have here, and then we're going to say 1 plus sine x into bracket du dx. So we are going to multiply to du dx, and our du dx is negative sine x, then minus our function u, which is actually cos x, times, and that's going to be multiplied to dv dx, and our dv dx is cos x, so this is cos x. Then we shall divide all through by v squared, and our v is 1 plus sine x, and then we're gonna square that. So but the main question is, show that f prime, the differential function, the derivative f of x, is less than for all values of x. So we ought maybe to try to manipulate this for quite some more time, and have this as f of x prime of x. So this is going to translate to, if I try to open the bracket, I'm going to get 1, this is actually going to run to, this time this is going to become negative sine x, and then if I multiply here, I'm going to have negative sine squared x, minus, if I multiply here, I'm going to get cos squared x. That will mean when I have this below, it will mean that this is going to be 1 plus 2. Okay, no need for that. I can say 1 plus sine squared x. Rather, no, we shall have 1 plus sine x squared. So I want you to look at whatever we have here, because we can be able to factor out the negative sign, and our function beautifully becomes negative sine x minus into bracket sine squared x plus cos squared x, and that is going to be divided by 1 plus sine squared x. No, that's an international crisis, so that's squared like that. Now we know that in the world of mathematics, that whatever we have at this part is going basically to run to 1, right? It's going to run to 1, and the whole of this, I mean, is going to run to 1, and that means we shall have minus our f prime is going to be equal to minus sine x minus sine x minus 1 over 1 plus sine x squared, which will mean that this can be written as negative 1 into bracket 1 plus sine x over 1 plus sine square and sine x then squared. So you see, whatever we are having at that given point, basically this if we cancel this, okay, for those who are not seeing what I'm seeing, we are going to say this is going to be into 1 plus sine x over 1 plus sine x into 1 plus sine x, and then at this given point the two will cancel out, and we eventually remain having f of x equals to negative 1 plus sine x, that point. So for all values of x, since this function is having a negative here, for all values of x, this is going to be negative. So f of x is actually going to be less than 0. It's going to be negative because we are having that negative at that particular point. A curve of the equation a curve has the equation y equals to cos x sine 2x. Find the x coordinate of the stationary point in the interval 0 x is greater than 0 less than or equal to half pi. So that given point, we are going to write the equation the way it is. We are told y is equals to cos x sine 2x, and that is the equation. Now we're supposed to find the stationary point. We have said that this at the stationary point the y dx is actually 0, so we are going to differentiate this, and we shall use actually product rule because we are having two functions multiplied together at that point. So we can say our u is going to be equal to cos x, and then we shall say our v is equals to sine 2x. Then since we are going to use product rule, you remember that we need to find du dx. So this is going to be du dx is actually going to be minus sine x, and dv dx is going to be, now we are going to use chain rule at this point because this is a function of x and the sine is also a function of x. So that will mean that we shall differentiate the inner function first. We are going to remain with 2, and then we shall multiply that to the differential of this without looking at the inner function, and that's going to be cos 2x. So that is what we are going to get, and that means we can be able now to say product rule. So if you have finding d of dx of two functions multiplied together, we are going to say is the first function u dv dx plus v du dx. So once we have that, we can basically we can now substitute the function that we were having at this point. So this is going to be dy dx is going to be equal to what? Our dy dx is going to be u, our u is this, so it will be cos x times dv dx. dv dx is actually 2 cos 2x, then plus what? Plus v, our v is sine 2x times du dx, and our du dx is negative sine of x. So the only thing that we have at this particular point is to go ahead now, try to simplify and put things in order, and that's going to be 2 cos 2x minus 2 sine. Okay, no, I think I'm just jumping the gun at this point. So this is going to be 2 cos x cos 2x, and then minus, we are going to subtract sine x sine 2x. So finding the decision point, and at this point we cannot be able to work anything out here without, okay, we can now say at the stationary point, at the stationary point at the stationary point, dy dx is equals to 0. So we are doing that so that we can be able to take whatever we have equated to, whatever we have gotten here as our dy dx, we equate that part to 0, and we shall see now this is 2 cos x cos 2x is going to be equivalent to sine x sine 2x. So what I was saying, this kind of an equation, you cannot be able to really work it out because you are having double angle at this point, and also you are having double angle at that particular point. So it's upon us to see how can we be able to try out and work it out in order to remove those double angle. But remember, this double angle here means that this is the same as 2 cos x. So this part that we have here can be written as sine. We can write it in terms of sine. Okay, we can write it in terms of cos squared x minus sine squared x. Yeah, can write that in that manner. Is going to be equal to sine x, and this term that we are having at this point can be written as 2 cos x sin x, or 2 sin x cos x. So at this point you can see I can divide also by this 2 cos x, and I can also divide here 2 cos x. Now at that given point I'll have all the right reserved according to the laws of maths, that I can be able to cancel these guys like that, and we end up having a very beautiful equation which we can be able to write at this given point and say this is going to be sine squared x minus, okay, let me just change this. This is going to be cos squared x minus sine squared x, cos squared x minus sine squared x is going to be equal to this, and this is going to give us actually sine squared x, and that means we can be able to take this on the other side of the equal sign and end up having cos squared x is equals to 2 sine squared x. So at this given point I can decide to divide by 2 cos squared x divided by 2 cos squared x. Now the reason as to why I've actually done that is to ensure that I can be able to cancel cos and cos, 2 and 2, and I will remain with tan squared x, because sine squared x over or squared x is actually going to be tan squared x, which is going to be 1 over 2, and that 2 is going to be coming from this given point. And then which will mean that I can be able to find the square root and the square root, and then I remain with tan x is equals to 1 over root 2. So if I'm finding the x coordinate, and I need to find the tan inverse of this part, so which will mean that this is going to be, our x is going to be tan inverse of 1 over root 2. And if I use and consult my calculator, I'm asking it, you guy, what is the tan inverse of 1 over root 2? And the answer I'm getting is actually 0.6154. And we're supposed to give our answer correct to 3 significant figures. So that means the answer you're going to write is 0.61, 0.615, 0.615, 0.615. And now that becomes the x coordinate of the stationary point.